Hello students, welcome back to our YouTube channel St. Wilfred College of Arts, Commerce and Science, Panvel. Today's my lecture topic is about synthesis of vitamins. In last two lectures, we have already seen what is means of vitamins. We have seen about their definition. After that, sources. After that, we have seen about their classification. As vitamins are classified into two types. First one is a fat soluble vitamins. Second one is a water soluble. There are some fat soluble vitamins and some water soluble vitamins. Today we are going to discuss about the synthesis of vitamins. In that we are going to discuss about synthesis of vitamin B1, after that vitamin B2 and vitamin K1. The first synthesis, which is synthesis of vitamin B1, it included synthesis of pyrimidine and thiazole moieties. After that, the second vitamin B2 is from 3,4-dimethylaniline and D-ribose. After that, the third synthesis, which is vitamin K1, it is from 2-methyl-1,4-naphthaquinone and phytol. Okay, so let's start with synthesis of vitamin B1. In that first step, this synthesis has a 4 steps. The first step contains, there are 2 reactants. First one is your ethyl acetoacetate and bromodiethyl ether. Okay, these are your 2 reactants. In this, what happened? This compound, if you are able to see, then this one is your carbonyl carbon, right? First we have to first we have to found acidic hydrogen atom. Okay, so if you are able to see, this carbonyl carbon has a 2 adjacent carbon atom. Here is one CH3, here is CH2. Okay, so in between these 2 carbon atom, we have to found which one has the most acidic hydrogen atom, which will remove with this Br atom as a HBr. Okay, as you are able to see that your HBr is your leaving group, so we have to find which hydrogen will remove. So after discussion, we will find out that that carbonyl group, which is adjacent to methyl, this hydrogen which is present on this methyl carbon atom is not that much of acidic compared to this. Why? Because you are able to see that there is one carbonyl group at one side, and second, this one is a ester group, right? Because of that 2 groups, that carbon has the most acidic hydrogen atom, so that CH2 has most acidic hydrogen. So the one hydrogen from this position will react with Br molecule. Okay, so let's see first what happens. When this reaction happens, Br break this bond. Br break this bond between CH2 and Br is an halogen, and halogen always, when they react, they take away their bond. They always take away their electrons. Okay, so because of that, this carbon will possess a positive charge. After that, one hydrogen from this carbon is removing, right? So when that hydrogen is leaving, hydrogen always leave as a proton, so it shifted its electron pair to the carbon. So because of that, this carbon has a negative charge. Okay, so this carbon has a negative charge, this carbon has a positive charge. So this positively charged carbon atom attack on this carbon atom, which is a negatively charged, and finally we will get this type of compound. If you are able to see, then this CH2, which was CH2 first, next it is a CH, because one H molecule is removed with Br molecule. Okay, and these 2 group as it is CH3 as it is. After that, carbonyl group is as it is. After that, only one hydrogen from this group has removed. This group, which is here, which is ester group, was as it is. After that, this compound has attack on this carbon atom. Only because of that, Br is removed and one hydrogen is removed. So our leaving group will be your minus HBr, that is hydrogen bromide, and this whole reaction take place in this in the presence of this solvent. Okay, this one is your step 1. Okay, we will move further for step 2. In step 2, if you are able to see, this one is our product for step 1, right? After that, we are just adding SOCl2 in that. Okay, SOCl2, whenever we are adding SOCl2, it just added one Cl molecule to this compound. Okay, but Cl will remove. Again, we have to find acidic hydrogen, right? So this carbon has the most acidic hydrogen. As we know, one hydrogen is already removed in first step with Br molecule. Right now we have SO2 and HCl. Okay, SO2 will remove and HCl will remove. HCl will remove from one Cl and one hydrogen. So one Cl molecule will attack on this carbon position. Again, what happened? That Cl will possess positive charge, this carbon will possess negative charge. So that positively charged chlorine atom will attack on this carbon atom and we will get this type of compound. Okay, our living groups are SO2 and HCl. Okay, next one. Okay, as we get this type of compound where one chlorine atom is added in the position of hydrogen, next step we are going to do is hydrolysis reaction. In hydrolysis reaction, what will happen? The group, if you are able to see that ester group, that is C double bond O, OC2H5, right? From that, this one is a carbonyl carbon, that is C double bond O, right? So when we are adding H2O, if we ionize it, we will get product as like H plus and OH minus, right? H plus and OH minus. After that, the O from this H2O will attracted by this carbon atom, which is a carbonyl carbon. Okay, so CO and again next O. So CO2 will remove. After that, the remaining OC2H5 will react. C2H5 will react with OH molecule. Okay, let's see again. First, this one is our component where our reaction going to form, where that CO2, okay, COO and C2H5, the bond between this compound will break. Okay, so CO2 will remove as a living group. After that, this C2H5 will react with H molecule or OH molecule of the hydrogen, and one hydrogen molecule is added at here, as H2O was ionizes in H plus and OH minus. OH minus will go with C2H5 and H plus will attack on this carbon atom. As when that carbonyl group leave, it will take away its electron pair. Sorry, the carbon will give its electron pair to the this next carbon. So that carbon has a positive charge. So sorry, negative charge. Because of that, this hydrogen will attack on it. So the compound which we get, it is in the keto form. After that, we are going to an enolization reaction. We are going to do convert of keto form into enol form. Okay, what happened in keto conversion? Same, that one H molecule remove. Okay, and this carbonyl group, which was C double bond O, means it is something like a ketone compound, right? That ketone compound is going to convert in alcoholic form. Okay, that C double bond O is going to convert in OH. Okay, and one hydrogen will remove, and that hydrogen will shifted its bond in between these two carbon atom. Because of that, we will get a double bond in between that two carbon atom, and this one is your enol form. Okay, next one. After that enol form, which reaction we are going to do? That is a condensation reaction. For that, we are adding one new reagent in that, one new reactant in that. What happened here? Let's see. The H molecule from N. Okay, there are two negative atom. If you able to see, then nitrogen and sulfur. These are the heteroatoms, right? Both have one hydrogen atom, right? That one hydrogen atom react with this OH molecule, the OH molecule and this one hydrogen. It will remove as a H2O. Water molecule will leave. Okay, and because of that, the bond between nitrogen and this carbon atom will take place. Okay, this bond will form. After that, you are able to see this carbon as a CH3, CH3. After that, second carbon CH2 or CH2O, C2H5, CH2, CH2O, C2H5. Again, yeah, again, we get Cl molecule at here and H molecule of here. HCl will remove. So HCl and H2O both will remove, and this nitrogen atom will attack on this carbon atom, and this sulfur atom will attack on this carbon atom. So finally, we will get one compound which name is a thiazole unit. Thiazole ring we get, and this one is our first second step for the synthesis of vitamin B2. Okay, next, synthesis of pyridine moieties. Okay, for this synthesis, as we said, we did two moieties. First one was a thiazole and second one was a pyrimidine. We get thiazole in last step. right now we are going to prepare pyrimidine moieties. Okay, first for that we need two reactant. We had taken 3-ethoxyethyl propionate and one ester compound. Okay, what happened in that reactant? Just one OC2H5 will group removed. If you are able to see the second reactant, that is OC2H5 will remove, but it remove with one hydrogen atom. What it did, it abstract one hydrogen atom from this carbon atom. It has a most yeah, it has a most acidic hydrogen atom. Okay, because of this carbonyl group, because there is one carbonyl group which is near to it. Because of this carbon atom, it has the most acidic hydrogen atom. Okay, so the hydrogen atom from this carbon atom and this OC2H5 group, okay, it will remove as a C2H5OH, ethyl alcohol will remove, and this carbon atom which has a aldehyde group will attack on this carbon atom again. Why? Because when that hydrogen will remove, it will shift its bond or its electron pair to the carbon. Because of that, this carbon has a negative charge. Okay, and exactly opposite at here, because OC2H5 is removing, O is electronegative atom, it will take away its electron from this. Because of that, this carbon possesses positive charge. So this positively charged carbon will attack on this negatively charged carbon atom and form one compound which has a aldehydic compound. Okay, after that we are going to add one again new reactant in that. Okay, after adding that, let's see that reaction will take place at which position. Okay, so first we are adding NH, right? N both are electronegative atom, right? So they will attack on electropositive compound. Okay, let's see where it will attack. First, that NH, okay, this nitrogen atom will attack on this carbon atom. Okay, and this nitrogen atom will attack on this carbon atom. After that, what happens? H from this molecule and OH from this molecule will remove as a H2O. After that, this OC2H5 and one H molecule from this nitrogen atom will remove as a C2H5OH, that is ethyl alcohol, and water molecule, they both will remove, and we will get one reaction, one ring, which is a heterocyclic ring actually. This one will be our product. After that, next reaction, we are adding POCl3 and ammonia in presence of ethyl alcohol. Okay, if we are adding ammonia, what happens? Ammonia, if we go for ionization of ammonia, we will get NH2 minus plus H plus, right? So that H plus from ammonia will attack on this OH minus and it will remove as a water molecule. After that, the NH2, which one was a minus sign, it will substitute on the position of a OH molecule, where our OH was present on that carbon atom, that NH2 will attack. Okay, so it is nothing but your substitution reaction, where what happened at here, that OH molecule is replaced by amine molecule, NH2 molecule. Okay, after that, next reaction is we are adding HBr molecule, that is hydrogen bromide. Okay, what happened at here? Again, that OC2H5 will remove with one H molecule, that is C2H5OH, that is ethyl alcohol will remove, and the remaining HBr molecule will be added at here. This position Br molecule will be added. Okay, so finally we will get our pyrimidine unit. We are right now we are able to see that in step 2 we get thiazole moiety, and in step 3 we get pyrimidine moiety. Okay, let's move further with step 4. Step 4 is nothing but an condensation of A and B unit. A unit was our thiazole, okay, and B unit was our pyrimidine. Okay, let's see first our thiazole unit and second one is our pyrimidine unit. What we are going to do? We are going to do condensation reaction of both these compound. For that we are adding HgCl, silver chloride, and we are going to reflux that reactant in solvent, which is methyl alcohol. Okay, so finally what happened? That CH3. Okay, if you are able to see, this is CH2Br. Here is one halogen molecule. Of course it will remove, but it will remove with one hydrogen molecule of this CH3. This CH3 will attack on here. So finally we will get this type of compound, which is our vitamin B1 called as a thiamine, and this one is your synthesis for vitamin B1. Okay, let's move further with synthesis of vitamin B2. Okay, For synthesis of vitamin B2, we need two reactant. First one is our 4,5-dimethyl 2-nitroaniline reactant, and second reactant is your D-ribose. Okay, let's see the reaction. What happened here? If you are able to see, there are two methyl group at 4 and 5 position, and 1 and 2 position there is a amine as well as a nitro group. Okay, and this one is our D-ribose compound. After that, we are going to do a condensation reaction in that. Okay, condensation reaction. After condensation reaction, what happened? One water molecule is revolved. Okay, one water molecule will remove. If you are able to see, okay, let's see this H, after that this O, and one H molecule from this amine. Okay, what happened? O molecule, after that H molecule, and the H molecule from this one amine. Okay, only one H molecule. So water molecule will remove HHO, that is H2O will remove. After that, our next reaction is what? That carbon will attack on this nitrogen atom. So finally, we will get this type of compound. One hydrogen from nitrogen is already removed from CH2 molecule, that is O and H, both are removed. So finally, our that D-ribose is condensed with this reactant. Okay, next reactant in that in same reaction, let's see. We are adding H2 and PD. H2 and PD are nothing but your reducing agent, right? So the reduction reaction will take place, but where it takes place? At position NO2. That NO2, which is a nitro group, after addition of a reducing agent, it is reduces to amine, that is NH2. Means reduction is nothing but what? It is addition of hydrogen molecule and removal of oxygen molecule. So NO2 will remove and NH2 will form. Okay, NO2 is converted into NH2 after reduction reaction. Okay, next, let's see, we are adding alloxin in that our this reactant. Okay, sorry, this intermediate going to react with the another reactant, which is alloxin. Okay, in that what happened? This okay, if you are able to see, there are two water molecules which are removed. Okay, two water molecule will remove. After that, we will get our final compound, which is nothing but your vitamin B2 riboflavin. But the reaction will take place at this position. If you are okay, let's see here. This compound, that is CS2, CHO, CS3, it will remove. After that, this nitrogen will attack on this carbon atom. Okay, OH molecule will remove. Okay, this H and OH as a H2O will remove. After that, next one, from this nitrogen, this H2 and this oxygen molecule. Okay, these are removed. So our two water molecule are removing from the adjacent carbon atom, and this two nitrogen atom will attack on this and this carbon atom. Okay, and finally we will get one product, which is nothing but our vitamin B2, called as a riboflavin. And this one is your synthesis of vitamin B2 with the help of thiazole and D-ribose. Okay, let's move further. Next topic is our synthesis of vitamin K. Okay, we are going to synthesize this vitamin with the from 2-methyl 1,4-naphthaquinone and phytol. Okay, these are our two reactant. First reactant is 2-methyl 1,4-naphthaquinone. When it react with phytol in presence of benzene and zinc chloride, we will get one new structure, which is a vitamin K1. Okay, let's see what happened in this reaction. That H molecule, only one H2 molecule is removed. Okay, H molecule from this 2-methyl 1,4-naphthaquinone and OH molecule from phytol. Okay, OH molecule from phytol and H molecule from 2-methyl 1,4-naphthaquinone is removed as a H2O. Okay, they both atoms will remove as a H2O, and this carbon atom will attack on this carbon atom. So finally, we will get this type of compound, which is vitamin K1. Okay, thank you.